So let's see if this works. It works. So you saw this slide in Mihai's presentation early. And what actually this represents are our algorithms, which try to help the car see, try to help the car know about the environment. Actually, there are pieces of code running on the hardware, which see different stuff from lanes, cyclists, free spaces. Now the question is how we make sure these things work, and they should work well, because you know, people's lives can be involved. So our colleagues, what they did, they added a lot of sensor on this car. If you want to see, just go by Miluța, and Miluța, can you wave for us, Miluța? Okay, so she's back there for the list. Believe me, it's a demo you don't want to miss. And this car is equipped with all kinds of sensors, and it gathers data. It's not the only car, it's a whole fleet. Now, there are a few issues. First of all, imagine how can we do debugging. It's like we're in traffic and we just check how the algorithms work. It's not working this way. We also need to make sure these things really work. I mean, if the algorithm in the camera see a red shirt, cyclist with a red shirt, we need to make sure that there is a cyclist with a red shirt. And we need to make sure that we test it on all possible scenarios or on all important scenarios. Now, how are we doing this? So first of all, we collect from the car this kind of data. Can means everything the car can provide. Wheel angle, speed, you name it. Then we run these algorithms on the cars, on these test cars, and we collect their results, what they return in some loggings. We collect location information. Of course, we have a video feed for what the camera saw, and we have a lot of sensors on it, radar, LiDAR, all kind of data that we collect. What we do, we take this data, and we're trying to send it. The thing is that we collect so much data that it's about 15 gigabytes per minute. Now imagine we have a whole fleet, and the first issue we have is that the internet is too low. So no matter how good bandwidth we have, and believe me, we have good bandwidth, it's not enough. So what we do, we just take those hard disks that are in the car, and we just ship them through mail, for real. And we ship them to our data centers, where we have a storage based on big data technologies, HDFS and non-HDFS, and here we have different issues. Together with this measurement data, we add what we call enhancing data. For instance, we need to know the street where the car is. We don't have this. We just take the location from the car, and then from additional services, we get this additional information such as the street, name of the town, all kind of stuff, the weather maybe. On top of this, we get what we call labeling data. What it really means is that somebody, a human being, is looking through that video feed, and it's with some tools, and it's making some notes that in this image there is indeed a car, bicycle, or whatever it is in there. We'll need this further. With all this data, we do what we call an ETL process. This comes from extract, transform, load. We extract the data from all these sources, we transform it so that to make it in a way we can use it further, and we load it in our systems. Here is one big challenge we have, because this process, it works with a lot of data, and the process of computing is pretty fast, but the transferring of the data between different nodes, it takes four times than the time of the processing. So for this, we need to use technologies like HDFS to work with the data, to process the data as close as possible to the source. And we run this with Apache Spark jobs. Generally, we use these stacks. Through this process, we get what we call metadata. This is basically, you can imagine it as a set of key value pairs from all that information, but imagine thousands of keys. Now, once we have this prepared, we are ready to index this. And from indexing, we can help our colleagues from which debug the algorithms with one first thing. They are able to search for sequences. This is how we call these files, 1 minute sequences, that are relevant for them. So they can search for sequences in highways. On highways, they can search for sequences during night, or this kind of stuff. And it helps them debugging. For them to debug, they have systems that are kind of emulators. We call them hardware-in-the-loop systems, which means a camera or a sensor, it is connected to the computer and can run the same measurement data as it would be on the road. But we need this first to have it identified. Still, this does not solve issues like I need to see, I don't know, sequences with cyclists on red t-shirts. So we moved a little bit further and we went to build some knowledge graphs. This is a very hot topic for us these days. And we are able to get a lot of more information through searches. And we found a new concept, which we call the scene. From 1 minute, maybe we have different kind of interactions with the environment. Let's say there is a right turn and then there is a overtaking maneuver. These are two separate things. Sometimes these maneuvers or these scenes are cross files. So through this semantic stuff we are doing, we are also trying to identify data that has some meaning, because the cars should behave the same when having a right turn. On top of this, we are trying to use the same data. This is how we prepare this metadata. This is why this ETL, it is very important. We are doing performance evaluation. How we do this is basically comparing different sources. So if you have an algorithm that sees, I'll go again with these cyclists, we'll compare the positions where this was seen with the data that we have from the people, from the labeling data. If it was reported on the same positions, then this algorithm worked. If not, there is an error, and then it should be taken, and it goes through all this process. Now this works fine, except that we have a lot of constraints. We cannot test only daily. We cannot test only during nights. We need to test in different countries, on different road types, with different weather types. There are a lot of conditions that could make the tests invalid, because if certain conditions are not tested, then we may fail everything. So what it actually happens, we need to know early when something is not wrong, when we need to go more in direction. And sometimes the drivers of the fleets are not experts, they're drivers. This is what they're good at. Or not all colleagues who will be downstairs. So what we are doing, we are sending a new, okay. Let's see how long it takes. Come on. Here it is. So we're taking a new feed of data, which is live data. This comes as fast as possible. We cannot say it's nearly live. This is what we call. But it's a small amount of data. It's about 1 megabyte per minute. This is how much data we record. And based on this, we are able to do a live monitoring, which means we are building some dashboards for which the managers in charge, the project managers in charge with these fleets are able to direct drivers in specific scenarios, to ask them where they should go sooner than later, because if we wait for the data to be shipped and to be processed, then it may be too late. I'll just go a little around security, because maybe I should have started with it, but here it is. So I'll just say one thing. So what we do, we have this DMZ on steroids. So basically what we have several DMZ layers with the most important data on the secure area. And we make data available for different beneficiaries depending on this level, how important it is. The basic is internet, and everybody can send only on the first layer, and from the other layer, from the back layers, connections can be initiated only to the first one. And this is sometimes very, very difficult to work with, to develop in this kind of environment, but we have to live with it. So that's about it. And if there is something that we learn from developing autonomous driving software, is that things should either be made simple or should not be made at all. Thank you.